Imagine a fighter jet approaching at combat speed. Radar systems scanning the sky detect almost nothing. Air defense networks show a nearly empty horizon, and then the mission is already complete. This is the operational design philosophy behind the F-35 Lightning II, one of the most technologically advanced combat aircraft ever built. And this is its full story. At approximately $100 million per aircraft, the F-35 Lightning II represents one of the most ambitious and complex fighter jet development programs in aviation history. It was not designed simply to replace older aircraft. It was designed to fundamentally change what a fighter jet is capable of doing. Imagine a fighter jet approaching at combat speed. Radar systems scanning the sky detect almost nothing. Air defense networks show a nearly empty horizon, and then the mission is already complete. This is the operational design philosophy behind the F-35 Lightning II, one of the most technologically advanced combat aircraft ever built. And this is its full story. At approximately $100 million per aircraft, the F-35 Lightning II represents one of the most ambitious and complex fighter jet development programs in aviation history. It was not designed simply to replace older aircraft. It was designed to fundamentally change what a fighter jet is capable of doing. Stealth, sensors, data networking, and precision strike capability all combined into a single multi-role platform. In this video, we break down the complete story of the F-35, how it was conceived, what engineering innovations make it exceptional, and why it is reshaping air power across the world in 2025. The F-35 program began in the 1990s under the Joint Strike Fighter competition. The United States military needed a single, affordable, multi-role aircraft that could replace several aging platforms simultaneously across the Air Force, Navy, and Marine Corps. Lockheed Martin won the contract in 2001 with a design that promised something unprecedented: one aircraft family capable of performing air superiority, ground attack, and electronic warfare missions across 3 distinct variants. The F-35A was designed for conventional Air Force operations. The F-35B introduced short takeoff and vertical landing capability for Marine Corps and Allied naval operations. The F-35C was engineered specifically for carrier-based naval aviation. Developing 3 variants simultaneously while incorporating cutting-edge stealth and sensor technology made this one of the most complex engineering programs ever undertaken in aviation history. The aircraft entered initial operational capability with the United States Marine Corps in 2015, followed by the Air Force in 2016 and the Navy in 2019. Stealth is the defining characteristic of the F-35, and it goes far beyond simply shaping the aircraft to reduce radar reflections. The F-35 airframe is constructed using radar-absorbing composite materials across its entire surface. Every weapon system is carried internally within 2 weapons bays, eliminating the radar reflections that external weapons create on conventional fighters. Engine inlet design prevents radar energy from bouncing off the fan blades inside. Even the canopy uses a metallic coating that deflects radar energy away from the aircraft. The combined result is an aircraft specifically engineered to be significantly harder to detect on radar compared to conventional 4th-generation fighters. This design allows the F-35 to operate more effectively in airspace that would be considerably more hazardous for older generation aircraft. While stealth receives most of the attention, many aviation experts consider sensor fusion to be the F-35's most significant technological achievement. The aircraft carries 6 infrared cameras mounted around its entire fuselage, a system called the Distributed Aperture System. These cameras give the pilot a complete spherical view around the aircraft in all directions simultaneously, displayed directly inside the helmet-mounted display visor. The F-35 also carries the APG-81 Active Electronically Scanned Array radar, one of the most capable radar systems ever integrated into a tactical fighter. All sensor data from radar, infrared cameras, electronic warfare systems, and data links is processed and fused into a single coherent picture for the pilot. This dramatically reduces cognitive workload in combat and gives F-35 pilots a situational awareness advantage that fourth-generation fighters struggle to match. The F-35A is powered by a single Pratt & Whitney F-135 engine, one of the most powerful fighter engines ever built, producing over 43,000 pounds of thrust with afterburner. Top speed reaches approximately Mach 1.6. Combat radius on internal fuel extends beyond 1,000 kilometers. In its stealth configuration, the F-35 typically carries two AIM-120 air-to-air missiles and precision-guided bombs internally, while maintaining its low radar signature throughout the mission. When stealth is not the primary requirement, external hardpoints can carry significantly greater weapons loads across a wide variety of mission types. The F-35 is operated by a growing number of allied nations, reflecting broad international confidence in the platform. Current operators include the United States, United Kingdom, Australia, Israel, Japan, South Korea, Italy, Netherlands, Norway, Denmark, Belgium, Poland, Singapore, and Finland, among others. Israel became the first nation to use the F-35 in combat operations, conducting strikes in the Middle East region beginning in 2018. United States F-35s have conducted combat operations across multiple theaters through 2024 and 2025. Each operational deployment has provided valuable real-world data that continues to drive software and capability updates across the entire global fleet. The F-35 program continues advancing through a comprehensive upgrade initiative known as Block 4. These upgrades include expanded weapons compatibility, improved radar capability, enhanced electronic warfare systems, and upgraded mission computing power. Block 4 also adds compatibility with new weapons, including the AIM-260 Joint Advanced Tactical Missile, a next-generation beyond-visual-range air-to-air weapon designed to complement and eventually replace the current AIM-120. Software updates are delivered continuously across the global fleet, meaning every F-35 in service becomes progressively more capable over time without requiring complete hardware replacement. This continuous improvement model represents a fundamentally different approach to fighter development compared to previous generations of combat aircraft. The F-35 program is expected to produce over 3,000 aircraft across all variants and operators over its full production life. Future developments include potential integration with the Next Generation Air Dominance 6th Generation fighter program, where F-35s may serve as forward sensor nodes coordinating with more advanced platforms. Artificial intelligence integration is being explored to further reduce pilot workload and improve threat response capabilities. The platform that entered service a decade ago is expected to remain a cornerstone of Allied air power well into the 2040s and beyond. From its origins as an ambitious joint program in the 1990s to active combat deployments across multiple continents in 2025, the F-35 Lightning II has delivered on a promise that many considered enormously challenging. A single aircraft family combining low observable design, sensor fusion, and multi-role capability at a scale no previous fighter program achieved. It has not simply changed what fighter jets can do, it has redefined what air power means in the 21st century. If you found this breakdown valuable, make sure to like and subscribe to Aviation History Hub. More military aviation history and defense technology content is on the way. We will see you in the next one.